So for this section, you guys are learning about sequence series and sequences. One thing to keep in mind is that if the difference between a sequence versus a series, because that's one thing that we'll use those words interchangeably. A sequence is going to be something like 3, 6, 9, 12, 15. So they're usually terms that are separated by commas, whereas a series are not going to have commas. They usually have plus or minus signs. So if we were to take this sequence and write it into a series, it'd be 3 plus 6 plus 9 plus 12 and so forth. So it's just a really small distinction. Same idea for this, and for sequences and series, we can look and find the differences and figure out that we're adding 3 each time. It's just the way that we show them is a little bit different. Sequences have commas, series may have pluses or minuses. And it would have minus if you had, for example, something like 4 plus 1 minus 2 minus 5 minus 8. In this case, we're subtracting 3 each time, so some of our numbers are negative. So we would write it like this for a series, but the sequence equivalent would be with commas. So just to have that distinction. Also, just to briefly review the differences between arithmetic and geometric, in case that wasn't explained in class. Sometimes it can be a little bit difficult if teachers just jump right in and don't give a brief explanation. So arithmetic, if you think of like arithmetic, we're dealing with just adding or subtracting. So we may be adding or subtracting the same number each time. So for example, if we have 8, 10, 12, this is a sequence, 14, we notice that we're adding 2 each time. And so that number 2 that we're adding would be considered the common difference. And we usually denote the common difference with the letter D. So in this case, we would just say D is equal to 2. The common difference is equal to 2. We're adding 2 each time. We use different words if we're dealing with geometric, but the idea is we're just trying to look for the pattern of how we go from one number to the next. So if we look at geometric are going to be things that are multiplied. We don't say divided, we say multiplied. So you can either be multiplying by a whole number or you can be multiplying by a fraction. So for example, if we have 4, 2, 1, 1/2, 1/4 as our sequence, we notice that to go from 4 to 2, we are multiplying by 1/2. Now, some people would say we're dividing by 2. We're going to actually use only multiplication here. So if we're dividing by 2, that's the same as multiplying by 1/2. So same idea here. This gets cut in half. This gets cut in half. We multiply by 1/2. So the number that we're multiplying by each time for geometric is called the common ratio. And that's with the letter R. We would show that with R. And so we would say R is equal to 1/2. So one way that we could distinguish between whether we have a geometric or an arithmetic, if they say D equals a number, D goes with arithmetic. That means you're dealing with an arithmetic sequence. If they say R equals a certain number, that means we're dealing with geometric. So R goes with geometric and D goes with arithmetic. So let's just briefly look at the equations that we can use to find these guys. And so the idea when we're finding formulas or equations, we're just trying to find an equation that explains how we can create that sequence so someone else could recreate it if they wanted to. So we have explicit and we have recursive. So I'll talk about explicit first. Okay, the explicit formulas that we'll talk about in a second are going to be the most helpful when we're trying to find different values. Recursive is easy to write, but it's not very easy to use. So if we go through for explicit, for arithmetic, the explicit rule we use looks like this. A sub n equals A1 plus n minus 1 times D. And D, we said, is the common difference. And I'll write the geometric up here as well, and then we'll kind of talk through what each of these terms mean. So geometric is A sub n equals A1 times R to the n minus 1. Okay? So if we talk about what these guys mean, and so one thing that is going to be slightly confusing for this section is what this A sub n means and what n means. So A sub n, I'll write it here, A sub n is your value. Okay? Whereas n is the term number. Okay? So as an example, let's say you have the notation that says something like A8 equals 14. What that means, if we were to kind of decipher what these numbers mean, that means this 8 means it's the 8th term. So it's the 8th number in a pattern. And the 14 means it has a value of 14. So its value equals 14. So the 8th term has a value of 14. So you can almost think of this as in terms of x and y's if you wanted to. The term is almost like your x, and the a sub n is almost like your y value, if that's a little bit easier to think about. So this is like your y, but this is like your x. So for these equations, we'll be plugging in things for n. So if we want to find the 20th term, we put 20 in for n. If we want to find the 80th term, we put 80 in for n to find that particular value. Okay, so A1 is just the first value. So what's the value of the first term? N is the number of the term number you're looking for. So if it's the 5th term, you put a 5 in there. D is your common difference. Over here, A1 is your first term. R is your common ratio, what you're multiplying by each time. And then N is the term you're looking for. So if we're looking for, let's say, the 3rd term, we'd put 3 in there for N. Okay. So if we look at the recursive rule, and we'll do a few examples with each of these formulas in a second. If we're looking for the recursive rule, for both arithmetic and geometric, they're going to start with the same information. One of the issues with recursive is you have to know the first term. So we always state, as part of our formula, we always have to state whatever the first term is, so someone knows where to start. And then for arithmetic, it looks like this. And so a sub n minus 1, this right here, that just means take the previous value. We know d is the common difference, that's what we're adding. So if someone looking at an equation that's in recursive form, they would know this is the first value, and what you're telling them then is if they want to create the sequence, all they have to do is take the value before and add a number to it. So for example, let's say that our first value was 3. And let's say, instead of this d, let's say they gave you 2 for that value. So the way that we would interpret this, if we had to recreate the sequence, is we would just take 3, that's our first term, and then to find this second term here, we just need to take the value before it and add 2. So 3 plus 2 is 5. And then according to the recursive, we just need, if we want to find the 3rd number, we just need to take the second number, the one before it, and add 2. So that would make it 7. So then likewise, if you wanted to find the 4th, this tells us if you want to find the 4th term, take the previous term and add 2 to it. So if we want to find the 4th term, the previous term was 7, we just add 2 to it, we get to 9. And so we can keep going that way. So the recursive rule is very easy to use if you have the first term, but we can see that the explicit is a little more helpful if you have if you want to find a term later in the sequence, like the 200th term. Because one issue with recursive, let's say we wanted to find the 200th term. Well, according to the recursive, if this is all we have is the first term, and we know what we need to do for the pattern, but in order for us to find the 200th term, we'd have to find the 199th first, and then add 2 to it. So that would be really hard to do. Whereas with the explicit, if we're trying to find the 200th term, all we have to do is put 200 in for n. So this equation may be a little more complicated to write, but it's a lot more helpful when you want to find numbers that are way down in the sequence. Recursive are easier to write because we're just writing the first term and this part for the arithmetic, but they're not very helpful if you want to find a term that's later on in the sequence, unless you want to sit there and write all the numbers out and keep adding 2 100 times. So I'm going to erase this for a second. Let's look at the geometric form of the recursive. So the geometric form for recursive is going to be A1. That, again, we have to state the first term. But for geometric, it's going to look like this. So you're just telling someone, take the first term, whatever it is, and multiply it by r to create the sequence. So again, if the first term, let's say, is 4, and let's say instead of r, we get a 2 here, then that would just tell you, if we know the first value is 4, and we want to find, let's say, the second value, this equation is telling us, take the value before it, so that's 4, and times it by 2, so that's 8. Now if we want to find the third term, we just need to take the second value, which is 8, and multiply it by 2, which is 16. So again, we can just, as long as we know the term before the one we're trying to find, we just need to multiply by 2 to keep going forward. So those is an overview of kind of those equations. So let's actually look at a few examples of how we use these. Just erase this. So let's say you're given something like some sequence like 6, 9, 12, 15, da, 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 da. So it'd be up to you to figure out, is this arithmetic, are we adding or subtracting, or is this geometric, are we multiplying? So in this case, we see that we're adding 3 each time. Okay, so it's going to be arithmetic, which means if we're writing the explicit rule, we have to use this formula. So let's just come up with a rule to fit this in case someone would ever want to recreate this sequence. So the first term is 6. We're going to keep the n minus 1 in place. The d value, that's what we're adding or subtracting each time. The d value is 3. So if we distribute this, we get 3n minus 3. So we get a sub n equals 3n plus 3. If we combine the 6 and the negative 3 together, we get plus 3. So what this tells someone is this is the equation that we can use anytime we want to create this sequence. So if they asked us to find the 500th term in this sequence, we wouldn't have to write it all out. We just put 500 in here for n. But this would be the equation that we can use. Okay, so let's try one that is geometric, just as a very basic one, just to kind of practice. As long as you have the basics down, the more complicated problems will kind of fall in place. So let's say we have 4, 16, 64, 256, and then it keeps going on. And our role is to create a formula for it. Well, we notice that this is multiplying by 4. To get to the next, we're multiplying by 4. So that is our common ratio, or our R value. So if this is geometric since we're multiplying. So to write a geometric rule, it would look like this. We just got to plug in our numbers. So we know the first term is 4. The middle, the R value is also 4. And then we just keep the n minus 1 there. And so just be careful. We can't combine these together to make 16. They have to stay separated because this is being raised to an exponent and this one's not. So what we would actually end up with as our final, and that would just be our final equation here. So if we should ever want to find the 8th term, we put in 8 in there for n and then solve it that way. Okay, so let's look at one that's maybe a little more complicated. So let's say they don't give you the sequence, because if you have the sequence, it's relatively easy to find the equation. Let's say instead they give you 2 random pieces of information. Let's say they tell you that a sub 5 equals 17 and a sub 15 equals 77. And that's all they give you, and they want you to write a rule. Well, the way we would interpret this means the 5th term has a value of 17, or the 15th term has a value of 77. So the way that we would write that, and they tell you also that it's arithmetic, so at least you know that kind of what general equation you're using. Okay, so if it's arithmetic, we have this equation. Only issue is we don't know the d, we don't know the first term. So there's a lot in this equation that we don't know. So what we would actually want to do, to find the d value, we can almost do the slope. You can almost think of these as like points, coordinate points. You can think of this as almost like 5, 17, and this like 15, 77. Okay, the d value is really just the slope, is how it's changing from value to value. So what we actually can do is use that slope equation. We can just do y2, I'll write it here, y2 minus y1 over x2 minus x1, and this will actually help us find the d value. So if we do 77 minus 17 over, so y2 minus y1 over 15 minus 5, we would get 60 over 10, which gives us 6. So that is our d value. So if we go back up here, we can replace this with a 6. Okay? So that's getting us halfway there. Now from there, what we also don't know, we don't know that first term so that we can finish this out. But remember, we have these guys here. We have these kind of like data points. So let's use one of them. I'm just going to use this first one. So I'm going to plug in 5 for n, because that was the fifth term. And then they told us, we still don't know a1, but they told us that somehow this whole equation gave us a value of 17. So I'm going to make this equal to 17 on this side so that we can figure out what that first term had to be. So we have 17 equals a1 plus 4 times 6. 5 minus 1 is 4, and times 6. So we get a1 plus 24 equals 17. We subtract 24 from both sides. We get a1 equals negative 7. So that's going to be helpful for us to complete our equation. So then we can go back up here. Now we know what the first term is. That's negative 7. Okay? And so just to simplify our equation a little bit, because your teacher's probably not going to want you to leave it like this, we do want to go ahead and distribute the 6. So we get a sub n equals negative 7 plus 6n minus 6. And then we want to combine those two. For our final equation would be a sub n equals 6n minus 13. And this equation is the one that fits those just by having those two data points. Okay? So let's look at an example for one like that for geometric. Let me just find it. Okay, so let's place this. So just to remember, if you have two random data points for arithmetic, you can actually just use the slope and go from there. So let's say for a geometric one, we're given, let's say a sub 3 equals, a sub 3 equals 10, and a sub 6 equals 300. And we know that it's geometric. But that's all you're given. So you're not given the r value, you're not given the first value. That's all you have is the third term is 10 and the sixth term is 300. So one thing that we'll keep in mind is that for geometric, the rule is this. Okay. Only issue is we don't know a1 and we don't know r. So we have to do some work to try to figure out what we can do there. So one thing that we can do, now because this is geometric, we can't use the slope like we did for arithmetic, but what we can do is we can set up two equations. I'm going to set up one equation using this information and one equation using this information. So we'll have two separate equations. So for this one, we don't know the first term, we still don't know r, but we know that this was the third term, so n was 3. And somehow all of this equaled 10. So I plugged in, this is like our x, I plugged that in for n. This is like our y, I plugged that in for what this whole equation was equal to. I'm going to do the same thing with this one. So we don't know the first term, we don't know r, but this was the sixth term. So I'll put in 6 for n, and somehow this whole equation equaled 300. Okay? So those are our two equations that we have. Now your teacher may want you to do substitution where you solve for a1. I think that can be a little bit complicated because you're dealing with fractions if you do that. An easier way I would suggest is to just divide the two equations. Now it doesn't matter whether you do this one divided by that one or this one divided by that one, but what I would suggest is that you always have whichever one has the higher exponent, put that one on the numerator, on the top. So if this is 3 minus 1, I'm just going to erase this. 3 minus 1 is just 2, and 6 minus 1 is just 5. So I'm going to divide them. I'm going to make sure this one's on top. So I'm going to keep that one on top, and I'm going to divide it by this equation over here. So I'm going to divide it by 10 equals a1 r squared. Okay? One reason why it's more helpful to divide is that then you can cross out your a1, which is fine. We have to solve for r. We can solve for r first. If we do that, 300 divided by 10 is just 30. Okay? And then what we can do is if it's r to the 5th and r squared, we can subtract them to get r cubed. Remember, if the bases are the same, you can subtract the exponents. Now to solve for r, we would do the cube root. So r, unfortunately, is the cube root of 30. It's not a nice even number. So our r is the cube root of 30. So what we could do is then go back up here and we can replace that r. We found out what that was. That's the cube root of 30. Okay. So then, from there, we can then try to figure out what the first term is. Well, now that we know what the R value is, we can use either this point, and we can think of this as like 3, 10, and this is like 6, 30. We can use that to then try to figure out what the first term is. So I'm just going to erase this. All right. So for right now, what we can do is I'm just going to use 3 and 10, use those. So yeah. So then what we can do from there is the value of the first term we don't know. The R we figured out was the cube root of 30. If we use this, the n was 3. So I'll put 3 in over there. And then this whole thing somehow simplified to give us a 10. So we can use that information to try to find out what A1 is. So we get the cube root of 30 squared, because 3 minus 1 is 2, times A1 equals 10. Now the cube root of 30 squared is going to be some crazy decimal. So let me actually figure out what that is as a decimal. So we would end up with, so this is still going to be 10. So we have 30 to the 1/3 squared. So this is 9.65 equals, 9.65 A1 equals 10. We would divide by 9.65. So then the answer would be A1 is about 1.04. So then what we can do there is replace the A1 with 1.04. So that would be our final equation. So just to recap, to find the R value, make 2 separate equations and divide them. Once you have your R value, use one of your 2 data points to plug it back in, putting the term number n for n and the value number n for a sub n, and use that to find your first term.